Hello there. My name is Devin. I am just going to share a quick overview of what I've been working on recently. This is a SIMD math library. For those unfamiliar with SIMD, if you're watching this, SIMD are a system of basically compiler communications that Intel has created, which are way faster than doing standard math operations like you see here. This is actually an overloaded operator, this thing. That is subtracting a vector from a vector. This stuff is the SIMD, right? If you're a SIMD expert, by the way, you might see some stuff in here that's not great because this is actually more of a way for me to practice and get better at SIMD. So understand I'm not an expert, but without further ado, I want to just get into what I've been working on. So this is just a test file. I'll get into that later. I have some functions lingering, like the collinear should be actually just in vector. But ultimately, I have these. You might be asking why, like, I have a SIMD square root and a square root. Well, it's mostly just data type returns. They actually both go through SIMD. I'm not actually doing any normal math operations. I don't really see a reason to, especially with SIMD being faster. So I ultimately just am returning a simple underscore M128 and converting that to a floating point for most of these functions, right? Gets a little uglier when we actually get into the reality of what some of the math behind this is. So ultimately, vectors are one of my more complete ones. Matrices are okay. I'm not even going to bother covering quaternions because actually I'll cover the one thing I did do. I covered, this. This is basically this is found online pretty much. This is converting a matrix to a quaternion, or making a quaternion out of a matrix. I'm not a big fan of this. I actually tried doing it away based on a math textbook, but so far I've run into problems with it, especially with imaginary numbers and things being out of range. I'm still learning quaternions. I'm, relatively unfamiliar with it from a deep understanding. I've only briefly covered them in the past and just learned to work with them through engines, so it'll be a fun deep dive to actually learn more about them. The matrices and vectors are, again, my most complete. Yesterday, I actually just did inversing and transpose. Transpose is pretty easy. That's just setting. This is the determinant. That is all simplified to one line. I just, put them down, but this is all return value optimized. Adjunct, not even going to bother to do that, as you can see. I did SIMD it, and it took me an hour. But anyway, so now I have this inversing and transpose, ultimately. The other thing I worked on with matrices was, shoot, I can remember. That might have actually been it. That might be all I want to cover. I still have yet to define a lot of these constructors, and maybe I'll get rid of some, kind of using some references here, and, I'll choose to delete or add things as I go. Vectors, I might have mentioned already, are my most complete. I have tons of operators for it. I've used kind of the multiplication for dot product, and the cross product I use divide. I don't know if I'll stick with those. Maybe not, but so far I'm liking the dot product this way. It makes it a lot cleaner for me. As far as scaling, yada, yada, yada. The other thing I've done is normalizing magnitude. This is just to help magnitude. I've also done projection, perpendicular, distance to line. Distance to line is just perpendicular magnitude. But anyway, that's vectors pretty much covered. I just want to show how some of this is working. This is just a little sandbox test that I've done. Matrix to quaternion, that is the correct value. I'm not going to explain. I've went through hours of testing that to make sure. Basically, yeah, I have projection perpendicular for these vectors up here. I got float times vectors. I also have a few matrices right here. This is matrix multiplication. And I have matrix D. This is where a lot of the magic happens. Determinant of D is negative 14. These numbers probably make no sense, so I'm going to just briefly gloss over this. This is just Rodriguez formula for rotating a vector about an arbitrary axis. I have also D times a scalar, inverse, and then, inverse. This is more to prove that, this return value optimization I did for inversing actually works. Something I've done in the past, but I just wanted to do a sanity check on it. So yeah, return value optimization, you can also assign something. But anyway, that is roughly what I've been working on. There's going to be more to come of this series. I plan to make it a series and like give more updates as I go. But this is just an overview of what I've done so far. And yeah, stay tuned. Thanks.